But data warehouses have traditionally been something that you run overnight and it spits out a report for you to look at in the morning. Maybe it's part of your monthly business review. It's not something that's on the critical path for your day-to-day business operations. But that's where Materialize is different because it happens in real time, because the core of it is the streaming engine. You can put Materialize into your core business day-to-day operations, pull all that data in real time, join it together, do the analysis live, and then take action on that data as part of your day-to-day business operations.
Which person influenced you the most in your career?
CTO of Cockroach, Peter Mattis, was my boss for a little bit. And he is an absolute machine when it comes to writing code and debugging problems.
If you could master one skill that you don't have right now, what would it be? Hey folks, Alex here. Today's episode is with Nikhil Benesch, who's the co-founder and CTO at Materialize. They're an operational data warehouse, really interesting stuff they're doing where if you have these expensive queries on your operational data, whether that's, Postgres, MySQL, Kafka, things like that, they'll ingest that in and sort of pre-calculate that for you. So if you've got these big joins, big aggregations, big computationally heavy things, Materialize all that for you using SQL. You can query it using, basically Postgres compatible interface and show that to your end users in a way that's not doing these big expensive queries on your databases, right? So lots of interesting stuff there. I love getting into the data infrastructure stuff of it, how they built it, how they think about billing, how they think about cloud primitives and what they wish they had. I thought Nikhil was very interesting on all these points. As always, if you have any questions, comments, if you have any guests you want on the show, feel free to reach out to me or to Sean. And with that, let's get to the show. Nikhil, welcome to the show.
Thanks very much for having me. Excited to be here.
Absolutely. So you are the co-founder and CTO at Materialize, which is a streaming database. I want to get all into that sort of stuff. But before we start, maybe just tell us a little bit about you and your background.
Yeah, so I first got exposed to the streaming data flow world when I was in college doing a little computer science research as an undergraduate. I worked on a streaming data flow system called Noria, a joint project between MIT and Harvard. And one of the people that kept coming up in that work was this guy named Frank McSherry, had done a bunch of foundational data flow work on a streaming data flow system called Naiad, which came out of Microsoft's research. This was back in, I want to say 2012, when that work happened, and I was looking into streaming data flow stuff as part of Noria in 2016 or so. And Frank had done some really seriously cool stuff, demonstrated crazy performance with the data flow system he had built. But then I set that aside when I graduated and went to work for a company called Cockroach Labs, building the open source Cockroach DB based on Google Spanner, horizontally scalable SQL. And I ended up at Cockroach because I had spent every software internship and job up to that point poorly re-implementing joins inside of applications because there was always some DBA or infrastructure team that was terrified of expensive queries being run on the SQL database. And I was really excited about the prospect of building a SQL database into the world that could scale joins, where you didn't need to worry about that kind of performance issue because you could just throw more computers at your database and have it scale effortlessly. And while I was at Cockroach, I met one of the other co-founders of Materialize, Arjun Narayan. And he actually encountered Frank McSherry while he was doing a PhD on a totally different subject, the thing Frank did before streaming data flow systems. And Arjun had become convinced as a result of Frank's later work, because he started following Frank after that initial exposure. He'd become convinced that incremental view maintenance via data flow systems was the answer to pretty much every problem in software engineering. And of course, that's not quite true, but there is something essential that captures, that so many problems are the result of your database has to go do way more work than it needs to do every time a query shows up, because probably it just computed the answer to that query a few milliseconds ago if it's powering the homepage of your application. Why is it pretending like it's never seen that query before and computing everything from scratch? So that seed of an idea really took hold for me. And when Arjun told me that he and Frank were considering starting a company based on commercializing that tech that Frank had built to bring that idea into the world, I knew I had to join. So that's how I ended up here at Materialize. That was 5 years ago now. So it's been a fun ride.
Okay, cool. And I'm glad you mentioned Noria, because I was going to ask how, I read a little bit about timely data flow and differential data flow, and I was wondering how Noria fit into that. So that'll be great. I want to get into that. I also think it's interesting that your career is basically just like taking these cool research papers and then implementing them as like, companies, both at Cockroach with Spanner and now, Noria and Dataflow at Materialize. So that's super cool.
For sure.
Maybe, I guess just to get us started, like what is Materialize? I see streaming database. Like, what do we mean by streaming database?
So funnily enough, we've actually tried to move away from the term streaming database. And the reason we've moved away from it is because it describes how Materialize works rather than what Materialize is. So the term we're using now to describe what Materialize is operational data warehouse. And what makes it similar to other data warehouses is that it's the place where you bring together the disparate sources of data in your business. So you might have 5 different application databases for 5 different microservices, and then your sales team is on Salesforce, your marketing team's on HubSpot, and 7 other teams have 7 other SaaS tools. And Materialize, like a data warehouse, is where you can bring all those tools together. But data warehouses have traditionally been something that you run overnight, and it spits out a report for you to look at in the morning. Maybe it's part of your monthly business review. It's not something that's on the critical path for your day-to-day business operations. But that's where Materialize is different. Because it happens in real time, because the core of it is the streaming engine, you can put Materialize into your core business day-to-day operations, pull all that data in real time, join it together, do the analysis live, and then take action on that data as part of your day-to-day business operations.
Gotcha. So it's not Redshift or Snowflake, which is going to be like slower, sort of lower concurrency type stuff, but it's going to be, higher concurrency, like a lot of transactions going against it, but still combining a lot of things and maybe, working against a good amount of data for that, doing aggregations that way.
For sure. And we actually simplify our lives in that the transactions occur outside of Materialize. You have upstream Postgres or MySQL databases that are doing all the hard work of concurrency control to put those transactions in a serializable order, enforce all the constraints. And then as soon as those transactions commit, those systems forward the information to Materialize. So we read off the bin logs of those databases, get all of those transactions in near real time, and then update all of the Materialized views to reflect the operations that have taken place almost immediately.
Gotcha. All right. And then can you give me just like a few example, actual use cases that like people like this is the problem they had and this is how they're doing it with Materialize?
Yeah. So I got to go on stage with one of our first customers, a company called Ramp. They provide credit card services to a bunch of startups now. And they started using Materialize last year to do fraud detection. They had a fraud detection workload that was running on a traditional data warehouse. And the reason they ended up in this situation is because to do fraud detection well, they needed to bring together a bunch of different information about users and transactions. And then they had a bunch of analysts who were able to very efficiently write SQL queries to look for patterns in the data, to find things that looked like anomalies, that looked like suspected fraud, and produce a report with all of the suspected fraudulent transactions. But they could only run that every 30 minutes. And the logic got so complex over time that it started taking even longer than 30 minutes for that report to run. And when you're doing fraud detection, 30 minutes is a long time. That's 30 minutes that somebody is out there swiping that credit card, spending money that's not theirs. And they were able to port that logic to Materialize without a whole lot of work because it's the same SQL under the hood, give or take minor syntactic differences. And on Materialize, that logic is up to date within seconds. So that same report is now available within just moments of the transaction occurring.
Yep, gotcha. Okay. And I see like that sounds really cool. When I see like in the docs, there are both like queries where I can run queries against Materialize directly. There's also syncs, which is like going to be producing stuff. It looks like into
Out to
Kafka.
Kafka, yeah.
Okay. Are most people using queries? Are most people using syncs? Is it like a 50-50 or like what does that sort of balance look like?
It's a pretty healthy blend. And what we'll see is that a number of our customers actually use both depending on the use case. And syncs are nice if you want a durable record of everything that has changed. And for auditability, people often want the whole log so they can look back 30 days and say, what did Materialize say was wrong with this transaction at this point in time? And if you're willing to pay the operational overhead of running Kafka and storing all of that data, you get some nice features out of syncs. But querying Materialize directly is really nice when you just want to wire up your application directly to Materialize and you don't want the overhead of running Kafka or another system.
Yeah, gotcha. Okay, sounds good. And then in terms of like the types of queries and things like these, are these usually like big aggregation type queries, where it's looking at a bunch of rows and doing counts and sums or things like that? Or is it even just like, just filtered stuff, but like just, straightforward filters and joins, but materialized rather than, doing all the compute at query time?
It's funny. This is one of the hardest things to explain about Materialize. Like, are the queries that you run on Materialize analytical or are they transactional? And for me, they err on the side of analytical with an important caveat. And I say they're analytical because they can be multi-way joins, like 15 different relations, extremely wide tables, what you think of as traditionally analytical queries, and then you slap them with an aggregation at the end, maybe some heavy filters, and you get a pretty nice, tight result set that had to look at tens or hundreds of gigabytes of data. But where Materialize is different from standard analytical tools is that it's not great for exploratory analysis. If you are asking a query for the first time, Materialize is going to be much slower at giving you the answer than a traditional data warehouse would be. They're hyper optimized for grinding over terabytes of data as fast as possible. Materialize isn't optimized for that. It wants you to declare your intent and say, hey, this one analytical query, super important that I always have this one up to date. And then you don't mind that maybe it takes 30 minutes for Materialize to get to the first answer for that query, because the point is once it's gotten the first answer, it's going to live update with every future answer every time the data changes from that point forward.
Gotcha. Okay. And so I go to Materialize, I create a Materialize view, and it's going to be just sort of building that in the background for a little while. But then once I have that, looking up an individual row is just like a individual row lookup in a table.
Exactly. And if you build an index on that view, Materialize will keep the results of that view in memory. And then a point lookup is basically just a hash map lookup. So it's super fast, like tens of milliseconds. And most of that is the latency of your request getting to the AWS data center and back.
Yep. Okay, cool. So what's happening like underneath the hood there? You mentioned like all these different data sources that are coming in, like what's going on Materialize then?
So there's three core layers of the database side of the house. We have the storage layer, which is responsible for taking the data out of upstream systems. So Postgres, MySQL, we have a webhook source now, which is a nice Swiss Army knife for disparate upstream sources, and then Kafka sources. So the storage layer takes the data from upstream systems and writes it to Materialize's custom persistence layer, which is a layer on top of S3. So it's super cheap, slow, but super cheap.
And that at that point, it's just like the raw data, like not materialized into view.
It's just the raw data.
Okay.
Exactly. Untransformed, written down in the order in which it came. And we have support for upsert semantics so that if you have a key, Materialize will eventually compact away the old values of that key so that you don't have runaway storage on these topics. But also it's on S3. So for a lot of users, they're never going to have so much data in a given topic that the cost is going to be prohibitive just to write it all down. Then on top of that, we have the compute layer, and that's really the heart of Materialize. And at the core of that compute layer is Frank's research. That's timely and differential data flow, which is the system that was derived from NIAT, that original paper I read way back when. And that is a stream processor built in Rust that before Materialize existed as a standalone library that people could download and write programs against. But to use differential data flow, you had to write a Rust binary, compile it, link it, and figure out how to. It didn't have any bells and whistles around it to make it easy to use in real production applications. But rock solid, super performant, incredible computer science research inside of that. And around that, we have built a SQL engine. So you show up at Materialize with a SQL query, we transform that into a data flow plan that gets rendered into a differential data flow program that's then executed with this Rust library at its core. And these data flows are very simple conceptually. You read the data out of S3, apply the data flow, and then spit the processed data out the other end. And the other end is potentially a materialized view if you just want to write it back to S3. an indexed view if you're interested in keeping that data in memory so you can efficiently do point lookups into it. Or you can chain a sink off of a materialized view and write what's in S3 inside of Materialize's world back out to Kafka or another external system.
Gotcha. Okay. So let me unpack that a bit. So you said that Rust portion, that's something that was created outside of Materialize and you all are using. Is that right? Yep. Okay.
That's right.
Interesting. And what's the timeline on that? Because Materialize is 5 years old. I guess like how old is Rust? Like, was this around 5 years ago? That like Rust binary thing?
Yeah. So I don't know exactly when Frank started on timely and differential, but they had existed for at least a year or two when I started working with them back in 2016. And I want to say it was about 2014, 2015 that Frank started working on timely and differential. So they were one of the early Rust projects. If you go back on the Rust community, you'll find Frank asking questions like, hey, my program's not compiling anymore. And they're like, oh yeah, sorry, we made a breaking syntax change to Rust.
Okay. Wow, that's amazing. Okay, so you do that. And then is it every time I create either a materialized view or an index, that's what'll create a unique like data flow program to be submitted to that binary?
Exactly. Yep. Those are specifically the two things that create data flows in Materialize.
Okay. Sounds good. And then the outputs of those go to, so if I have a materialized view that's not indexed, that's going to be on S3. So now if I'm doing queries against that, we're looking at like maybe like a couple hundred milliseconds probably for a lookup for that. Is that right?
It's often even worse than that because we don't optimize our S3 format for point lookups. So we have to load potentially way more data than people expect in order to answer those sorts of queries. And we have plans for fixing this eventually, but for the moment that's out of spec for Materialize. That's a you're holding it wrong moment. And if you want those fast lookups, we tell people create an index so it's all sitting there in memory.
Yep. Okay. Sounds good. So talk to me a little bit about sources, because you mentioned Kafka, and then also there's like Postgres, MySQL, and all that. When I'm looking at the docs, there's like a dedicated Postgres connector exporter type thing. And then for other ones, there's like Debezium, which is basically like, getting into Kafka that way. What's the story? Like if I'm using Postgres, should I be using the direct one? Should I be using Debezium in Postgres, or like, how should I think about that?
We definitely push people to use our direct integrations where they exist. So at the moment, that's just Postgres. MySQL is launching later this quarter, which we're very excited about. And the reason we started building out these connectors natively instead of always pushing people to use Debezium and Kafka, it's twofold, really. One is folks who don't already have Kafka and Debezium set up found it operationally challenging to have to go introduce Kafka and Debezium into their organization. And one of the big value propositions of Materialize is that it makes streaming easy. And we like to say that it makes streaming so easy that you don't even have to think about the word streaming. And that means that Kafka is a hard thing to suggest to people because Kafka is often exactly what these organizations that are not streaming first are trying to avoid. But that said, we pair really well with Kafka. So for organizations that do have Kafka and Debezium already, it's still very much a first-class integration. It's just we don't want to force that choice on people if we can help it. And then the other thing is consistency. We want to be able to reflect upstream transaction boundaries inside of Materialize. If you write to two different tables in one transaction, Postgres or MySQL will atomically update the database so that you can never see the update to one table and not the update to the other table. And Debezium does not export that transactional metadata in a way that's easy to consume. It's an option you have to enable, and we couldn't find an efficient way to ingest that information. Whereas if we read from the Postgres bin log directly, or if we read from the MySQL bin log directly, that transactional information is right there in the bin log format, and we can make sure to only show you atomic updates in Materialize as well.
Gotcha. Can you tell me a little bit about consistency in Materialize? Like you have a section on this, which I think is really interesting. I think it's like just like a weird problem to think about. If I have, 5 different upstream data sources, what does consistency mean within Materialize, given those are coming in at different times, or who knows? Like, what does that sort of look? How do you think about consistency?
That's a phenomenal question, and I have a somewhat unsatisfying answer. So the answer that exists today is consistency largely starts at the moment the data arrives in Materialize. So if you have 5 different upstream systems, we don't know how to relate a transaction in one system to a transaction in another system. They could have happened in either order. We just don't know. Maybe there are timestamps, but you can't trust the timestamps because there can be little skews in clocks. So we don't try. Right now, we write down the time of ingestion for every transaction. And whatever order that happens to be in Materialize is the order that we declare to be correct. But what makes this still a valuable property to provide is that we commit to that order inside of Materialize. So if you have 10 downstream views, all querying different subsets of your 5 upstream sources, you're always going to see consistent data across those views. And if you start a transaction in Materialize and then read from any number of those views, you're going to see exactly the same data from all the upstreams reflected in all of those views. So you at least get a consistent snapshot within Materialize. Something we're launching this quarter is a feature called real-time recency, which gives you consistency between Materialize and basically one upstream system at a time. And the specific guarantee, so if you see a write succeed to Postgres and you have real-time recency enabled in Materialize, you're guaranteed that your next read to Materialize will include that write that you saw. So you get a read your writes consistency property.
Are you like enabling Materialize as a replica of Postgres, or like how is that sort of working?
Yeah, so we worked with Kyle Kingsbury from Jepsen on this. He's the one who came up with the term real-time recency and suggested this approach. And it's a phenomenally simple approach once you hear it. What Materialize does in this case is when a query arrives, it reaches out to the upstream system. So Postgres, Kafka, MySQL, and asks for the latest offset. For Postgres, that offset is the LSN of the last transaction to commit. Similarly for MySQL, for Kafka, it's just the latest offset in the topic. And then in Materialize, we wait for that LSN to flow into Materialize, get committed to our storage layer, and then flow through the compute layer. And that guarantees that because as a user, you saw a write commit to Postgres, and then you ask Materialize a question, we go ask Postgres, hey, what's the latest transaction you've seen? And there's an ordering guarantee there. We know that Postgres will tell us an LSN that includes the LSN of the transaction that just committed. And now you're guaranteed that Materialize is going to show you data that reflects that transaction.
Gotcha. Okay. Wow, that's super sick. What'd you say the sort of timeline on that was?
We're going to be launching this in preview this quarter. But the big open question for us is, what is the performance? Because this introduces this synchronous request to Postgres on every query, and you're forced to wait out the data flow propagation delay. And our current estimates are this is a second or two. And for a lot of people, they're coming to Materialize for responsive reads, and waiting a second or two for every query to succeed is not going to work for their use case.
Gotcha. Is that something that you like enable on a per query basis, or will it be, hey, if you set up this Materialized view, it's also enabled with real-time recency, and therefore every query to this Materialized view has that enabled?
We're thinking on a per session basis. So you connect to Materialize, you set a session variable saying, I want to opt into real-time recency, and then every query you do gets these real-time recency guarantees.
Yeah. Okay. Sounds good. Tell me a little bit like about S3, like I see so many like sort of data infrastructure stuff using S3.
For sure.
Just like what's the sort of reasoning there of instead of local disk and that sort of replication using S3 as sort of that foundational layer?
Economics is the fundamental answer. It is so cheap to store data on S3. If you throw it on S3, you kind of don't have to think about it. You can put a terabyte on S3, and for most organizations' budgets, that doesn't register at all. And that is not true of local disks. That's not true of EBS. A terabyte of EBS is something that starts to register for people. Now, Materialize recently learned, this is in preview right now, to spill data flow state to disk. Up until a couple weeks ago, Materialize had to store all intermediate state and indexes for data flows in memory. And disks are expensive. Memory is wildly expensive. So that was not economical for some use cases. But we've built our own memory allocator for Linux that enables paging out to disk. So those data flows now actually do make use of the locally attached SSDs on the machines that they're running on, and that brings the cost down and brings stability up, because you don't hit this wall when you run out of memory. You start spilling to disk instead. So we actually do make use of local disks now. It's just not something we rely on for durability. The durability comes from S3, and the local disks are there to provide performance.
Gotcha. Okay, and this is probably a stupid question because I don't understand the internals, but you said like to enable that spilling to disk, you wrote like your own memory allocator to do that. Was that easier than just like tweaking the data flow thing to write to disk itself? Or I guess like how did you sort of approach that sort of problem?
It was. The way that the data flow engine works, the way timely and differential have been built, they're really smart about how they write to memory. That's maybe the key thing that Frank and his co-researchers at NIAD did to make NIAD and then timely and differential perform so well. It basically always accesses memory sequentially and is very careful to avoid random accesses into memory, because that clears the cache and those memory accesses become much more expensive. And that's exactly the same trick that you want to play when you are reading from disk and writing to disk. You want as much of that to be as sequential as possible. And by building this as a new memory allocator, nothing about the data flow engine had to change, and its access patterns were already nearly optimal for accessing disk. So that just ended up being the right place to slot this in. The initial thought was actually to do something even simpler and just enable swap. Just tell Linux, feel free to swap out whatever you like. But for various operational reasons, it ended up being easier to have a little more control. And the memory allocator gives us enough control without having had to write a totally separate implementation of these core data flow operators to be disk backed instead of memory backed.
Gotcha. Okay. And then, okay, so let's say I sign up for Materialize. I get like a large size compute or something like that, submit a few Materialize views with these sources. Do I have like one box that's like my own that's running this? Or is it multi-tenant? Is it split across a number of boxes? Like, what does that sort of architecture look like?
Yeah, it's deliberately abstracted away from you as an end user. We want you to not think about this to the extent possible. So let me first describe the end user experience, and then I'll dig into how it actually works on the back end. But the way it's meant to feel as an end user is that you get access to a Materialize region. And we're upfront about this being a specific data center of a specific cloud provider. So we only run in AWS at the moment, but you can choose between something on the West Coast, something on the East Coast, and something in the EU. And once you're in that region, it's meant to feel like you have this unlimited pool of Materialize compute and storage resources available to you. But you do have to explicitly indicate when you want to bring a use case to Materialize. And we call that a cluster. So you'll type create cluster, and then you have to pick a size for the cluster today. Right now, it's t-shirt sizing, small, medium, large, extra large. So mirrors EC2 instance sizes. The difference is when you get to 2x large and 3x large and 4x large, we will invisibly start scaling across multiple machines. We don't tell you where that point is because we want the flexibility to dial around the inflection point on our side without users noticing. Maybe we have a bunch of small machines, or maybe we have one huge machine. It shouldn't matter to you as a user. But this cluster has one really important property, which is data flows running on it. They crash together, but they also share state together. So their lifetimes are all bound together. If this cluster runs out of memory, all the data flows that were being maintained by that cluster evaporate. But the reason you might want to put everything on one cluster instead of sharding it across clusters is if there's intermediate state that's usable by multiple data flows, co-locating them all together on the same cluster lets them share that state.
Okay. And when you say intermediate state, that would be like actually me creating a Materialize view and then two or three other things reading from that material, like also using that Materialize view, or what's that look like?
Yeah, so that's explicit intermediate state that you as the user have control over, and it can make a lot of sense to build things like that. But there's also invisible intermediate state that Materialize will create for you automatically in order to make the data flow efficient. And the Simplest example of this is a join. In order to efficiently maintain a join, you need indexes for both the left and the right sides of that join. So when a new left record shows up, you need to see if it pairs with anything on the right. And if that meant scanning over the entire right collection, way too slow. But if you have an index there, that's a really efficient lookup and it's an efficiently maintained join. So that's invisible to you as a user. But if you had multiple data flows that were doing that same join and you created those indexes on a cluster and then created multiple downstream indexes, all of them would be able to reuse those intermediate indexes in their computations.
Yeah, very cool. Okay. That makes me think of something that's just like when you're providing these sort of like data infrastructure things, at some point you want to like hide some of that lower stuff, like so people don't have to think about it or so that you can change it around. But also you want to expose enough so that they can like optimize and understand that, like you, instead of having two different clusters that are both have that join and now are both maintaining that intermediate state. I guess like how do y'all think about educating your users with that? Is that, do you do a lot of that with the docs and things, or do you just sit down with them and talk about that? Or like, what does that sort of look like? Just sharing enough of the internals that they can get efficient usage out of it.
It's probably the biggest challenge in Materialize's adoption right now is teaching people how to use this system because it is so complex and there's such specific domain expertise that you need in order to understand why Materialize is using memory, how you can get it to use less memory. And it's very similar to a problem that the industry has had for decades with optimizing database queries. You have to think about the optimizations differently, but at a meta level, the problem is very much the same. You need a DBA who deeply understands the optimizer and can look at the explain plan for a query and help you understand whether it's making efficient use of indexes, whether there's a specific new index that you should build, whether you maybe need to rewrite that query a little bit to help the optimizer along. So we do what we can with docs, but there's a big hands-on component today. We have a great field engineering team that helps onboard new customers, sit down with them, understand their use case, and sometimes, if necessary, go line by line through a SQL query and talk about what's expensive and how to rewrite that SQL query to be more efficient and Materialize.
Yeah, interesting. And are there things like explain plans for these data flows or something like that to get a sense of like what's happening or like
exactly?
Yeah, okay.
That's the big interface for understanding what the data flow looks like. You can type explain, and there's 4 different variants. There's the raw SQL plan, there's the optimized plan, and there's a low-level plan. And users are not meant to understand all of these themselves. We have documentation for the ones that are user accessible, but then some of the other ones are there for when we need to really go deep with a particular user on a particularly problematic query. We're also trying to build out visualizations in our console. So when you sign up for Materialize, the first thing you see is this web interface, and it'll drop you into a web-based SQL shell. So you can start playing around with the SQL interface because that's still the primary way that people interact with Materialize. But once you've gotten data flows up and running, the console becomes even more powerful because we can visualize that data flow for you. And the graph is a much more natural, intuitive representation than the textual explain plan. So we're investing in that as fast as we can because that really just brings the data flows to life for people.
Yep, very cool. You mentioned, pulling in a lot of different sources, and you mentioned, not only your Postgres database, but things like HubSpot or other SaaS tools. Like, how do they get from HubSpot or something like that as a source into Materialize?
You have 2 options today. One is painful, which is you write a custom microservice that pulls the data out and puts it in Kafka. This actually works fine if what is upstream of Materialize is already a custom microservice. It's less palatable if you just want to pull Salesforce data into Materialize. Why are you investing in the tech to build that connector? But the interim solution we have right now that works quite well is webhooks. For a lot of these upstream tools, they can emit webhooks. They have some native plug in a URL, and we will send events to that URL. And then in Materialize, you see those raw events, and they're in a pretty raw form, but SQL is actually a pretty good tool for manipulating those webhook really events. So you write some cleaning Materialized views, and then you get the events in a pretty usable format. But also launching this quarter, we're really excited about it, is a Fivetran destination. So we'll be able to plug into the universe of Fivetran connectors, and they have pretty much everything under the sun. And then you can natively have Materialize on the other end. And if you're willing to pay for one of their higher tiers, you can get the sync frequency down to a minute, which feels pretty real time. But it does leave a little bit of the value of Materialize on the table because we can get updates every second and be just fine. And the reason Fivetran doesn't do this is because if you're updating traditional data warehouses, a Snowflake or a Redshift every minute, that's already starting to stress them out. And they don't have a ton of pressure to get that faster, but they are working on turning the internals of Fivetran into a streaming system so that they can ultimately deliver on syncs that are faster than every minute. And we're really looking forward to that future.
Cool. In terms of like most popular sources, like, do you see a lot of sort of SaaS things like that? Or is it a lot of, operational databases, Postgres, MySQL, and Kafka stuff that like is generated internally from a company? Or like, how do you see that breakdown?
Yeah. So this is anecdotal, but the rough sense is most people show up at Materialize with a specific piece of data that they want to bring into Materialize for one use case. And that's usually something in a Postgres or MySQL database or something in Kafka. And there's a critical need to operate on that data faster. And that's what pushes them to reach for a tool like Materialize. And once they get used to Materialize, once they see how powerful Materialize is, they start dreaming about use cases that they hadn't considered. And those use cases often look like, well, I already have this critical data in Materialize, and I have some other data in my CRM that if I could just bring that into Materialize, that would feel really easy. It'd be a really quick way to build an application. And that's when they start reaching for bringing their SaaS tools into Materialize. Segment data comes up a lot for us because there's usually just a fire hose of data at every organization that's running through a CDP. And that's very easy to plug into Materialize now with the webhook source.
Okay. Very nice. In terms of like that webhook source, do you charge like per webhook, or is that just part of the compute that they're paying for as part of their cluster? Like, what does that look like?
Yeah, so we bill for two things today. It'll be three things ultimately. One is the storage cost, just literally our S3 bill passed on to you.
I was doing the calculations and it was like right on track with like the actual S3 stuff. And I was like, yep, okay.
Yeah, no, we pulled up the AWS prices and we just copy and paste those over. It's the same thing that Snowflake does because that's not where we provide value. That's not what we want to take margin on. So we bill for the compute, and each cluster, each t-shirt size consumes a certain number of credits per hour, and that reflects the underlying infrastructure cost plus our margin because that's where we provide people with value. And we trust with the webhook sources, we cover our costs basically by charging for the storage, and we want you to actually transform that data, and that's where you actually pay for Materialize. One day we'll charge for networking as well, but right now networking is included.
Like bandwidth width across like
egress bandwidth. Yep. The inbound is free because of AWS, and the outbound is quite expensive as it is with all the major cloud providers.
Yep. Interesting. And so is that outbound that's like when people are actually querying their data and getting it back, or using it when they're putting it into a sync? Or is it even the networking as part of your data flow type stuff?
I don't think we would ever charge for the inter-AZ fees that we accumulate on our side, but that's not a commitment. Don't hold me to that.
Sure. Yeah.
And in terms of egress, we have not quite decided what makes the most sense. The most extreme version is every byte transferred out of Materialize, whether in response to a select query or whether as part of a Kafka sync, or even as part of, say, a Kafka source, because there's a little metadata chatter that goes back even as a Kafka consumer. Would we bill for all of that? Potentially. Or would we take a more Snowflake style approach and it's just the bulk data unload? So Kafka syncs in our case that we would bill for. And maybe we'd abstract it away. It's not literally bytes over the wire, but how many messages sent over your Kafka sync? But we never answered these questions. And right now it's negligible enough that we're just giving it to users for free, and we'll figure it out at some point in the future.
Yeah, it's interesting just talking to like data infrastructure founders and just how much sort of network fees. It's hard because like customers don't love paying for them, but it's like it's got to get paid for some way, you know.
But somebody has to pay for it, at least as long as the major cloud providers are charging for it. So,
yep, exactly. What do you think about network egress fees? Like, do you think mostly racket? Do you think it's like, oh, there's a real cost there, and we need to like incent people to economize on that? Or like, what are your thoughts there?
I don't have an informed take. I am confused about the situation where the tier 2 players are giving bandwidth away for free, and the tier 1 players are charging what seems like an exorbitant rate. And that's where my understanding stops. I don't know enough about the internal dynamics on these things to understand what's going on. I do think it's suspicious that all 3 major cloud providers charge approximately the same amount for bandwidth, which some people think is exorbitant, which makes me feel like there really are truly costs here. And it would be extremely difficult for these cloud providers to stop charging for it. Because I want to believe that GCP would start giving away bandwidth for free if they could afford to do it, to start eating at Azure and AWS's business, but they're not. So my sense is there's some real costs there, but I wouldn't bet money on it. It could be something else.
Yep. When you talk about tier 2, are you talking like Cloudflare and their like zero egress type stuff? Is that what you mean?
Yeah, that's maybe an unfair framing. I'm just thinking in terms of market share.
Yeah, exactly. One person explained to me who had worked at AWS and saying, the hard part is like, there's inbound and outbound, and Cloudflare has like such an overbuilt network in terms of inbound for like DDoS attacks that they basically just like have essentially free outbound. So then for them, they can sort of give it away for free, but I don't know. I don't know enough about this stuff either. So I just try and pick it up from everyone.
Yeah, I mean, that sounds plausible to me for sure. But yeah, I'm not a networking expert, so.
Yeah. We talked about S3 a little bit. What about S3 Express One Zone? Is that something interesting and useful to you? Hey, not quite there yet. Like, what are you thinking about that?
It made waves at Materialize when it was announced. I think everyone took a pause that afternoon to try to understand what it was and follow the discourse on Twitter. And we're friends with the WarpStream guys, Richie and Ryan. So we were chatting with them about what it meant for WarpStream, because Materialize's persistence layer actually looks quite a bit like what WarpStream does under the hood to store data. And if the chronology of these businesses had been different, there's a real chance that Materialize would have been built on top of WarpStream instead of building our own persist layer. And there's something really interesting there in terms of the latency that you get. And if we could move write ahead logs off of slow S3 to fast S3, the latency for Materialize would come way down. And the way this will actually present for us, it doesn't bite people much right now with Materialize, because you don't really notice the S3 latency because you build indexes on the stuff you care about, and then it's all in memory. But real-time recency is what exposes the latency of writing to S3, because we don't want to show you any data that we have not committed to S3. And when the commit to S3 is on the critical path, the way it is for a real-time recency query, you have to wait out the data coming from Postgres to Materialize, then the S3 commit, which is often the slowest part, and then the data flow propagation. So if we can minimize that, real-time recency, instead of being a 1.5 second penalty, is maybe a 100 millisecond, 200 millisecond penalty. And now you're in business for a huge variety of use cases, and you didn't have to give up consistency, which is really cool. The economics are challenging. That's what I've heard. We have not run the numbers in detail ourselves, but what I've heard from Richie and some of the other folks who have started evaluating it is it's expensive. It's a privilege to use S3 Express One Zone. And I don't know if that's fundamental, if that's going to come down over time the way S3 costs came down over time. And the other question I have is, they called it S3 Express One Zone. It is a mouthful. And is that because S3 Express Multi-Zone is coming in the near future? And that would save us some engineering effort, because we wouldn't trust writing to just one AZ for our durability. We'd have to write to 2 AZs, and now we're writing to S3 twice, and it's more to manage. We'd love to offload that problem to Amazon. So that's the thing we're waiting to see. Just get a little more information about how the economics work out, what the future plans are for S3 Express. before we do too much of an investment in it.
Okay, cool. Yeah, I'm excited to see how that changes things. Especially, I think that multi-zone thing will be, where you just have to write once and not worry about that. Yeah, that's gonna be interesting. One last thing, just sort of technically and stuff. So you'll have Postgres wire compatibility in terms of querying. Is that a case of actually re-implementing Postgres and all that, or are you sort of using the Postgres, query planner and engine at the front end, and then putting it into your indexes and S3 at the end?
It is a full re-implementation of Postgres. And we adopted this approach, this philosophical approach from Cockroach. So it's funny, Cockroach is a Go re-implementation of Postgres, and Materialize is a Rust re-implementation of Postgres. And we actually did consider the question in the early days of, should we take Postgres, fork it, and graft timely and differential into it? And there are days where I wish we had done that, because on the dark days, somebody comes with a bug in Materialize and there's some little edge case and you discover some behavior in Postgres. And you're like, oh my God, why is all balls a valid timestamp in Postgres? Like, where did that, and you go read the source and it's allegedly some military expression for midnight. And then you go add that to Materialize. And when 7 of those happen in a row, you start to wonder if you made the wrong choice. But the flip side of that is Materialize really cares about computations being deterministic. The correctness of the system falls apart if anything non-deterministic slips into the data flow execution layer. And Postgres is riddled with non-determinism. That's not a slight. It's very useful, but like the random function, people use that all the time. And Materialize cannot support it because we can't do deterministic execution if you're randomly generating numbers in the middle of a data flow. So we'd be finding a totally different class of bugs that may have been intractable if we'd forked Postgres. But we'll never know for sure. We'll never know that counterfactual. But yeah, we did end up biting off re-implementing all of Postgres's parsing and planning in Rust.
Okay. Wow. Yeah, that's a big job. Okay, let's talk a little bit about sort of just like business aspects, pricing, billing, things like that, especially billing and data infrastructure. I guess like how you talked a little bit about your billing model. How did you sort of think about that, and how much work went into thinking, how do we bill? How many factors do we have for billing, and just that whole process?
So our CEO, Arjun, went deep on pricing and looked at a bunch of other cloud databases to understand their pricing models, talked to some of the people who had built out those pricing models in the early days. And then as far as I can tell, I went into a hut, had to think for a couple of weeks, and then came out and said, this is the answer. This is how we're going to bill for Materialize. And it's worked pretty well with one asterisk, which it's an interesting philosophical question, which is we bill cost plus. So we take our costs, take a margin, and then pass those along. And this creates a weird incentive for the engineering team, because every time we optimize a query better, that is money that a customer is no longer paying us, because they can go size down that cluster and now they're using less Materialize. And what you have to believe is that making things more efficient means more people will be able to use Materialize. You'll make it up in volume. And we do believe that. But there have been some optimizations, like spilling to disk, where we've realized, oh my goodness, we have just fundamentally changed the economics of Materialize because of this pricing model. So it's not perfect. But what I do like about it is that it forces users to use Materialize in a cost-efficient way. They can't find edge cases that cost us a lot of money. And anytime you do value-based pricing, there's always these edge cases where somebody shows up and is like, oh, the thing I need this product for is dirt cheap. And it ends up being wildly expensive for the infrastructure provider. And then there's this game of cat and mouse where they have to put limits in place, but maybe those limits disrupt other valid use cases. And maybe you have hard conversations with people about like, hey, you're just not going to be a customer of ours because our pricing model doesn't support you. So I think it's weird no matter what you do. And when we've talked to people, everyone has this experience in one way or another. It's just hard to get right.
Yep. What's the relationship like with, you said you're currently all on AWS. Like, is there a close relationship with them in terms of like optimization and things like that? Or is it like, you're you're mostly on your own until you and just keep figuring this out and that sort of thing as a provider on top of AWS.
It's close and getting closer. As we expand our AWS footprint, we're that much more meaningful to their direction. And we've been chatting more and more with their product teams about what EC2 instance types would be interesting to us in the future. Especially 2 quarters ago, we were not as certain that we would be able to roll out spill to disk as quickly as we could. And we were really memory hungry. And by default, AWS really only has an 8-to-1 memory to gigabytes of memory to CPU ratio. Those are the memory optimized instances. And they have these crazy instance types that offer way more memory than that, but they're really expensive. They're not part of their main EC2 offering. And it's still interesting to consider if they were to roll out a even more memory optimized instance with a 12-to-1 ratio or a 16-to-1 ratio. Would that be better for Materialize? So it's been really nice to be able to chat with their product teams to understand just how far off market are we with our requests. Do you have a bunch of other customers who are asking for instances that look like this? Redis is another AWS customer that's worked closely with them on designing some instance types. And we're actually moving over to one of the Redis Labs promoted instance types. It's this i4i instance class. And they have like 30 gigabytes of disk for every gigabyte of memory, which is 5 times more than the other AWS instance types with disk. And that's going to be really valuable for us as we get better and better at spilling to disk.
Nice. Do you expose, like, say I choose a large cluster, do you expose sort of infrastructure metrics to customers like CPU usage or memory pressure or anything like that? Or like, what's that sort of look like as a user?
Those are exactly the 2 that we expose. And it's your responsibility as a user to see how much CPU and memory your data flows are using. And we do our best to present that to you. And the console every day gets better at showing that to you and identifying, hey, this data flow is expensive. And it's because this index inside of that data flow is using 30% of the memory on this cluster. We've thought about adding more data flow specific metrics because CPU usage for a while was just 100% all the time. And for us, we're making perfect use of the CPU. We're doing as much work as possible. And for users, that was very stressful. So we thought about, is there a different metric we should expose, which is like amount of useful work this data flow is doing each second? And if that starts getting close to 100%, now you have a problem. And what we ended up doing instead was changing how timely data flow worked to use less CPU. So we made the CPU usage metric meaningful instead of introducing a different metric.
Gotcha. And if I'm sort of running out of if I'm, having CPU or memory issues, what's going to happen are my Materialize views just going to lag? And then do I can I just increase a cluster in place, or what does that look like?
Alter cluster set size equals medium, large, whatever's bigger than what you're currently running on.
Okay. Because I imagine the compute is pretty stateless, right? Like you could just, since everything's on S3.
Yeah, and it can take a fairly long time to bring a new size of a cluster online, especially if you're running a large cluster and you need to go to extra large. You're maybe thinking 20, 30 minutes, maybe talking 20, 30 minutes for that to come online. We call that rehydration because you've got to go read all that state from S3, re-perform the computation on all of it, and get back to where you were. But we offer tools and are getting increasingly good at building automation around this so that you can turn on the new size, wait for it to come online, and then turn off the old size. So right now it's kind of all or nothing. Either your data flow is keeping up and the lag is 1 second or less than 1 second, or you've hit the wall and you have fallen behind and you can no longer query Materialize. And that's not a great user experience because you go from no performance problems to immediate outage. And spill to disk is changing this fundamentally because as you start spilling to disk, you start going slower and slower and slower. And as the disk fills up, you go even slower and you start lagging behind even more. But you have a warning period.
There's warning. Yeah.
Yeah. And while you're lagging, it's not like you can't see the data. You're just getting increasingly stale data. So maybe your data is 5 minutes out of date now. But that, for your use case, may be fine. Not great, but it may be tolerable. And that gives you time to turn on the new cluster at the new size and let it catch up without it being a total outage.
Very cool. Okay. Last thing on billing. So it looks like a mostly managed model. Do you have, man, I can't remember what Sam Lambert called it, but it's like a cloud side model or something like that where people can run Materialize like in an account that they own or anything like that. Have you thought about anything like that? Or is it just like, that hassle's not worth it? Like, the managed version works for us. Like, how do you think about that?
Like a BYOC, bring your own cloud model.
Yeah, exactly. Yep. Where it's still like in AWS, but it's maybe an account they control and you're just sort of hooking into it or, yeah.
We've definitely thought about it and we've definitely gotten a lot of requests for it as well. I'm personally a bit of a BYOC skeptic because I don't think it changes the security posture that much. Empirically, yes, organizations seem to be much more comfortable if they can run your scripts in their AWS account. But when you actually zoom out and look at it, you end up with a control plane that has admin API credentials into the customer's VPC that can do essentially anything. So it provides some minor security and privacy benefits, but I'm not convinced that they're all that robust. And then you have a huge debuggability problem as the cloud provider. We get CPU and memory profiles live streamed from everything that's running in production. And in some cases, we've had seg faults happen in production. We can go run that process under GDB if we have to and pull out every piece of debugging information that we could ever want. And it's completely untenable to do that in a BYOC model. Like the customer, if you're lucky, will get on a screen share with you and type some commands on their machine while you watch, but you're never going to get a live interactive debugging shell with GDB. And that's really been an unlock for our velocity. We get to move a lot faster controlling all the infrastructure.
Do you think people will still be asking for BYOC a lot in 5 or 10 years? Or is that just like, hey, we're in this transition period where people don't understand what's mine, what's yours, managed, unmanaged, like things like what do you see that sort of future looking like?
I used to have a stronger hot take on this that I've softened in recent months. So I think if you can pull off the fully managed service model like Snowflake did, like Materialize is, that works really well because nobody actually wants to be in the business of keeping this stuff up. They just want to trust your security and privacy controls. It's really hard to bootstrap those controls. We've invested a lot in Materialize, in security and in privacy and getting our SOC 2 certification and performing regular audits and access control and all sorts of internal infrastructure to make sure that anytime an engineer looks at production infrastructure, we write down every command that they ran. They have to get approval from another engineer, all that kind of stuff. And that's hard to do as a small company. So I can imagine that BYOC sticks around as a way of bootstrapping new infrastructure businesses into existence because they have to get started somehow. You have to get your first customer somehow. And it's very capital intensive to get to the level of SOC 2 certification and controls that you need to win enterprise deals. So I don't know. I don't know how that dynamic is going to play out over the next decade, but I'll be very curious to see. Have you heard of Nuon? I think I'm pronouncing it right.
No, I haven't. What's that?
They are BYOC as a service, a recently launched startup, and they provide a framework for companies to build BYOC products. And I think there's something really interesting there because they provide this like Terraform provider skeleton and log exporter that's all integrated with their platform. So you put a Terraform provider in Nuon and then they handle a bunch of the orchestration around operationalizing the BYOC deployment of that, showing you what customers are doing, when they're lagging behind, you can force update them. Like maybe that's the way forward. That mitigates the pain of building out the BYOC infrastructure.
Yeah, that's interesting. I feel like there's a company, 5 years ago that was helping with just sort of like on-prem installs of these things and doing upgrades and things like that. And I can't remember I want to say like Replicated, but I don't think that's it. Something that was like helping with that. But now, yeah, cloud version of BYOC version. That's pretty interesting.
Yeah, so Nuon is exactly that for BYOC.
Okay, that's interesting. On that same note, like you mentioned the difficulties of like building a data infrastructure startup as a small team, getting that momentum going. Like, are there any sort of either cloud primitives or companies or things that would have made this a lot easier that you wish existed either from AWS or maybe something else like Nuon, like that would have just made any of this process easier?
I'm going to cheat and throw an answer your way that came from one of your other software Huddle interviews, which is Foundation DB as a service.
There we go. Okay.
I don't know why this doesn't exist. I want it desperately. What we actually do is use Cockroach DB. So we're Cockroach Cloud customers. But it's funny, the way we use Cockroach is we created a table that's essentially key comma value, and we do inserts, updates, and deletes into that table as point reads and updates. And we basically use none of the SQL features of Cockroach DB. We use it as a hosted implementation of Raft where we can get support and get someone on the line if something goes wrong. But we would love if Cockroach offered a simpler API so we could get at key value stored directly, or if AWS wanted to run etcd or Foundation DB as a service.
Yep. Is Dynamo like too expensive, too slow? Like what's the...
Too slow. We looked at it because that's AWS's answer, but the commit latencies are, I want to say the P99 is at least 100 milliseconds, and that's just way too slow for us. The Cockroach P99 commit latency is single digit milliseconds. It's like, I want to say 6 or 7 milliseconds, and it's often closer to 2 or 3. And that's what we need in order to update our metadata without it showing up in the user experience.
Gotcha. That's interesting. Foundation, I've heard from a few people just like, yeah, I want to know more about that because it's showing up in different places. It's kind of a cool thing. So
yeah.
Cool. That's great. All right. I want to close off with just like some common questions that we ask everyone. So semi-rapid fire here. But here you go. First one. What wastes the most time in your day?
Slack.
Okay.
Yes. The interrupt driven nature of Slack.
Yep, exactly. Do you turn it off, or do you like and have deep work, or do you just always have it available? I imagine like as CTO, you have to.
I have moved my entire sleep schedule around to get 3 hours of focus time, about 11 p.m. to 2 a.m. Eastern. And that's when I'm able to do deep focus work. That dodges the people on the West Coast and dodges the people in Europe. So that works pretty well.
That's amazing. Yep. Okay. If you could invest in one company, it's not the company you work for, not a public company, which you actually could invest in, but like, a non-public company, who would it be?
WarpStream, without a doubt.
What tool or technology can you not live without?
Polar Signals has become that for us. They do continuous CPU profiling. We started working with them a year ago. You drop in a Kubernetes daemon set, runs an agent on every node, and it extracts CPU profiles from your entire production infrastructure.
Wow. Okay. Very cool. Which person influenced you the most in your career?
CTO of Cockroach, Peter Mattis, was my boss for a little bit. And he is an absolute machine when it comes to writing code and debugging problems. He will just jump to definition in the Linux kernel if that's what it takes to find a bug. And I, to this day, am so inspired by the number of problems Peter was able to track down with that approach and the number of things that Peter was able to code while also being CTO of Cockroach.
Yep. How much time do you get to code now in your role as CTO as Materialize?
Very little. I'd say 5 hours a week on a good week. And that's coming out of like magic time, nights and weekends. That's not coming out of my core working hours.
Yep. And is that on sort of core Materialize stuff, or how do you choose what to work on when you do get the 5 hours?
It gets harder and harder because I want to work on stuff that's important but not urgent. And finding those projects, they also have to be increasingly small because I have such limited time. And in order for me to feel like I'm delivering value, I need to be able to, over 4 weeks and 20 hours of work, do something meaningful. But there have been some wins like that recently that have been satisfying. But that's always what I'm on the lookout for. Where is there a tiny little thing that's not on the critical path, but will be really meaningful if I'm able to knock it out, pick it up.
Yep. And there's still just like nothing like sitting down and accomplishing something in code. It's like clear if it works or doesn't work. It's not like people stuff or marketing or whatever else. It's like, the clarity of it. It's
for sure. I'm an engineer at my core, and there's just something so creative about the process of software engineering. Like that was my art form growing up. I can't draw, I can't sing, I can't paint, and I can code and I can make things that way. And that's always been really fulfilling for me.
Yeah, I agree. Cool. If you could master one skill that you don't have right now, what would it be?
I wish I had any musical talents. Completely unrelated to the job, but that is something I am just very much lacking.
That's like when you said like the no music, no art, that's sort of my thing. If I had one skill, it would be like design like be able to do just like some amount of design, and it helps in other areas too. But yeah, something creative outside of software. All right, cool. Last question. With AI in the news and all that, what's your probability that AI equals doom for the human race? Are you worried about that?
I'm not worried about it. And I'm happy to be wrong on this point, but
I wouldn't be too happy to be wrong about that.
uh, many times throughout human history, we have examples of people predicting that the next thing was going to bring doom to humanity. And so far, they haven't been right. Of course, bias in this, right? Because the moment that they're right, humanity ceases to exist and it's all over for us. But they said the Industrial Revolution was going to change everything. It didn't. We're still here going strong. And I feel the same way about AI. I'm not convinced that it's gotten anywhere close to the point where it's going to supplant humanity. I think we're going to find some way to peacefully and happily coexist with ChatGPT, at least in my lifetime.
Yeah. Very cool. Well, Nikhil, thanks for coming on. Like, this was awesome. I'm jealous of, like the very cool things you've done, both, Cockroach sort of implementing Spanner and now working to Materialize and implementing Dataflow and Noria, all this stuff. So awesome what you're doing. Thanks for sharing your time with me.
Thanks for having me. I'm jealous you get to spend your days doing this, talking to a lot of really, really cool folks. So yeah.
Yep. I should have said, sorry, where can people find out more about you, about Materialize, if they want to find more?
Yeah, so go to materialize.com. We've got an active Slack community. There's a big banner. Jump in there. You can reach out to the engineering team in there. We monitor it pretty closely, and we'd love to chat with anyone who's interested about Materialize or the underlying tech. Timely differential, we still get a steady stream of questions on that, and happy to dig into the technical details there with anyone curious.
Cool. Oh, great. Nikhil, thanks for coming on.
Thanks for having me, Alex.